So this is what I'm marking you on for analysing. 3 dot points. The first one is correct, relevant processing of data. The second one is thorough identification of relevant trends, patterns, relationships. So you can see in the QCAA chemistry exemplar, they have, using their graph, they have indicated a relationship between the concentration of an electrolyte and the hydrogen gas. Okay, so they're talking about what is the relationship basically between their dependent variable and the independent variable, which is where in your report? Where can you find your dependent and independent variable in your report? Your research question, right? Okay, that's the second dot point. Thorough means basically use data, use scientific words to explain the relationship. Don't just say this one increased, this one decreased. Like, that's not thorough. Okay, you need to show a bit of evidence like data. Okay, the second dot point is thorough and appropriate identification of uncertainty and limitations of evidence. And this is where it kind of melds a bit into the discussion as well, because they're related. So, if you didn't know, uncertainty is related to precision. You really need to get used to this. Uncertainty means precision. So whether it's precise or not precise, depending on your uncertainty. Okay, so you use those calculations to quantify precision. If you have a high uncertainty, what does that tell you? It's not precise. Okay? The other one is accuracy. So you calculate error. If you have a high error, that means your experiment was not accurate. So in the exemplar from QCAA, they have the limitations. So you can see some key words in this. Can you see imprecise? So the time recorded for each trial is inconsistent, and hence the average time is unreliable. You've got to use that word. Varying times for collecting a sample volume of gas indicates that the raw data for the time is inconsistent and therefore imprecise. So that's an example of a limitation looking at precision. You then use that to talk about errors in your discussion. I'll come to that in a moment. Okay, so that's basically analysing. The discussion is taking that and going a little bit further. So the second dot point, discussion of reliability, validity. So what does that mean? Accuracy, precision is related to reliability, validity. So if an experiment is valid, that's because it is accurate. And that's because it has low percentage of error. And that shows that there are no systematic errors. So all of these words are linked together. The experiment was not valid because it was not accurate or inaccurate, because it had a high percentage of error. And it had a high percentage of error because it had a systematic error. Does anyone know what a systematic error is? Okay, so we've got an example from QCAA. They collected gas, which they're saying is inaccurate. If you jump to the third column, the gas produced is not collected, and the volume of gases collected is a mixture of gases rather than just hydrogen. So it's a systematic error because they're not collecting just hydrogen. Okay, they're always making the same error. It's systematic. Okay, so if you look to the second circle, see how it's not in the middle, but they're making the same error over and over. Okay, so it's a systematic error. So the first two columns are the limitations. The last column is the discussion of the validity, talking about an error that was made, a systematic error. Okay, that is validity, that is accuracy. The second part of a discussion is the reliability. Reliability is all about precision. So here's an example. The time recorded for each trial, I already mentioned this, is unreliable. Second column, it's imprecise. And the third column, which is the reliability, validity, it's talking about the uncertainty. So it's mentioning data and it's talking about reliability. So it's not reliable because of a random error. See down the bottom? Okay, so that's the second dot point. The first dot point, I skipped over it, is your conclusion. Basically, it's a thing at the very end, and you're linking whatever conclusion. It's not super long, this bit. It's a couple of sentences. You need to answer the research question. So any assessment you do in science, you'll have a question, you actually need to answer the question. So you use scientific theory and mention key data, so just a couple of data points to support your conclusion, and that makes it a justified conclusion. Last thing is suggested improvements and extensions. So the third dot point, suggested improvements and extensions to the experiment are logically derived from the analysis. So you need to think of an improvement. I would say at least 2 improvements, 2 extensions that are logically derived from the analysis. So what errors were there? What was your systematic errors? What was your random errors? How could you improve these systematic random errors by improving the experiment or extending the experiment?